All right, we're going to start off with the idea of the surface area of solids with planar faces. What is the surface area of anything? It's the total area of all the outside or external faces of the object. An object with planar faces is one where all the sides are flat. So if I looked at this cone, would that be planar? Are all the sides of this flat? No, it's kind of round, conish on the outside. However, if I looked at this pyramid here, are they all flat? Yeah. So that's what we're talking about here. The formula for the surface area of an object with planar faces is literally this. The surface area is the sum of the area of all the faces. If I say sum, what operation is that in maths? Addition. Well done. Okay? So, a minute or so, can you get that formula down? Don't talk yet, I just need to catch. So for example, you just told me that this pyramid was planar. Okay, what are the external faces of it? If I open it up, what shapes do we have here? Good. So you would be summing together the area of the four triangles and the square at the bottom. The problem with that is right now, I am assuming that you know how to find the area of the shapes that make up the flat faces. But in case you didn't know, and hopefully I've established to you, I never assume anything. It makes an ass out of you and me. Okay? So I'm going to teach you, whether you remember it or not. What is the area formula for a square or a rectangle? Because someone remind me of that. Length times width. So get that down. Please do a real quick diagram of that situation. The area of a rectangle is length times by width. What's special about a square versus a rectangle? They're the same. Both sides are the same. So it'll be side times by side. Okay? You know, diagrams don't be ruled or anything. It just has to remind you of a rectangle. And you need to know how long one side is, how long the other is. And then the area is the length times by the width. Does anyone know off the top of their head what the area of a triangle is? Keep going. I like the base times by height part. Divided by 2. Good. Base times by height over 2. You don't need to copy this part in purple down. But why is it divided by 2? Because any triangle is always half of a rectangle here. Do you agree that in purple, have I drawn the remnants of a rectangle? And is this part of the rectangle the same as that triangle there? And is this part of the rectangle the same as that triangle there? So hopefully that proves to you that any triangle is always half of any rectangle. That's why it's the same formula as a rectangle but divided by 2. So can you get those two down for now? The area of a square or rectangle and the area of a triangle, those two for now. See? 80. Let's do it first. So try one. If you get it wrong, you can ask it to. Does anyone know off the top of their head what the area of a circle is? You don't need to know. I'm fixing it now.
Circumference radius.
It's a
circumference times 2 divided by 9?
it's vague there. Let me fix that now, okay? it sounds like you're mixing up. The circumference of a circle is like the line around it, so the perimeter of it. So the circumference around a circle is 2 pi r, but I'm asking for the area. So how many little squares goes into that circle shape? So the area of a circle is actually pi times by the radius squared. And please, you need to remember that bed mass is not an option. So that small squared, you need to do that first. You need to square the radius and then times it by pi. All right? Even my ignites was stuffing that up. That would be pi times by the radius, and then they times that whole answer by itself to square it. No, the only thing being squared is the radius here. So square the radius first and times it by pi. Parallelogram, you probably wouldn't know what this is, but that parallelogram there, does it look like a rectangle that I'm blowing over? It's leaning over slightly. The area of a parallelogram is literally the same as a rectangle. It's base times by the height. Only one more shape, and then we'll practice one together. All right, last shape before we practice. A trapezium looks like this. So you've got 2 parallel lines. One is shorter than the other, and they're connected by these diagonals here. The area of that is whatever A is, the short one, plus B. Divide that by 2, and then you times the whole thing by how tall that shape is. Can you get that formula down, please? This part you don't need to get, but this is for me to help you out. Knowing these formula for 2D shapes, it lets us find the area of each flat side of a 3D object to find its surface area. So based on that, those 5 formulae there, do we have the formula we need to find the area of the bottom of this? Do we have what we need to find the area of the sides of this? Could we times the sides by 4?
Yeah.
We're assuming that the pyramid is like properly made. I get the trapezium, but I want to demonstrate because pyramids are quite tricky. Okay? Because you're going to be told most of the time how tall the pyramid is. So how tall is straight up and down? Right? Are the sides of the pyramid straight up and down? Straight up and down would be from the middle here to the point. But can you see how the sides are diagonal a little bit? So even my other class, they're telling me that this... They're telling me that this here, so from the middle of this up to the top, they're telling me that that's exactly 4 centimeters, is it? No, it's going to be slightly different, okay? So, what you need with pyramids, because it's tricky, I don't know how tall that triangle is, because that triangle is leaning over. So I need to do something with right-angled triangles. Does anyone know the name of the guy that has to do with right-angled triangles? His name starts with P. Pythagoras. So for us to find this purple line, which is the height of the triangle, we need to use Pythagoras. So I'm going to draw a little right-angled triangle over to the side here. How tall does the diagram say the pyramid is? How tall? Like straight up and down? 4. Tells you it's 4. Now, That whole base of the triangle is 6, but I've cut that triangle in half. So how long would this bit of the right angled triangle be? Say it loud. Half of the base. The whole thing is 6. I've cut it in half. So that bottom would be 3 centimeters. So according to Pythagoras, a squared plus b squared equals c squared, the hypotenuse squared. So a could be 3, b could be 4, and I don't know what c squared is. That's what I'm trying to find out here. What's 3 squared? 3 times by 3? 9. What's 4 times by 4? 16. So 9 plus 16 is 25. What was the opposite of squaring something? Square root. The little c is going to be the square root of 25. And because it's not algebra anymore, we can completely forget about there being pluses and minuses. Because does having a minus length make any sense in the real world? No, we can ignore that. So we're just dealing with real numbers. So C, this line here, this wonky line, is 5 centimeters. We didn't know that. We only knew how tall the pyramid was. We didn't know how long or how high that wonky triangle was. So let's find the area of the pyramid equals. What would the base be? What would the base of this pyramid be? What shape would the base of that pyramid be? Rectangle, square? It's a square. You're being told that it's 6 by 6. So you've got 6 times by 6. Is that the only surface of the pyramid? Yeah. What else? What other shapes do we have on the outside of this pyramid? How many of them? 4. Good. So we've got 4 lots of. And according to our students here, he knew the base of the triangle is 6 times by the height of it, which we had to use Pythagoras for, which is 5 over 2. So that's all my working there. Notice no algebra, it's just plugging numbers into the formula. You've got 36 plus, what's 6 times by 5? 30 divided by 2, 15 times by 4, 60. So the area of that pyramid is 96 square centimeters. So the sides, and the bottom. Let's find the area of the rectangular prism underneath. So area of... You do not have a formula for the area of a rectangular prism. The formula is the sum of all the sides. Which sides are the same in the rectangular prism? Is there a side that's the same as the one that I'm pointing out right now? Where? On the bottom, there's 2 of those. Good. And because the bottom is a square, what can you say about all these rectangles that go around the outside? Are they all the same or are they different? They're all the same. There's 4 of them. Okay? If one of these sides was like 8, they wouldn't all be the same. So here, the area of the rectangular prism is going to be 2 lots of 6 by 6, which is the top and the bottom, plus the 4 sides, 4 lots of... What would the area be? What numbers would I times together to find the area of this rectangle here? 8. 6 by 8. Well done. 6 times by 8. So that is 2 lots of 36 plus 4 lots of 48. I can't do that off the top of my head. Two times 36 plus 4 times 48. I get 264. No, that's what the calculator said. If the calculator's wrong, I'll throw the Samsung in the bin. Is that the end of the story? Is that the surface area of this shape?
No.
What would I have to do with those two numbers?
Very good question.
Add them together. So total area is 264 plus 96. You could stop there. But if we were building this thing in real life, is that square inside going to be exposed? So if we wanted to be a realistic surface area, the external, how many squares do I need to take off of that 360? Why 2? Can you explain?
Because there wouldn't be the one in the middle if it was like because it's not solid.
You're correct. It's just, yeah, we'll work on explaining it. Did we find the area on the bottom of the pyramid?
No.
That's the 6 by 6 here.
Yeah.
Did we also find the area on top of the rectangular prism?
Yeah.
You're telling me that those shouldn't exist because they're not exposed. So how many squares do I take off? 2, like you said. So total exposed area is going to be 360 minus 2 lots of 36, 2 squares. So 360 minus 2 times 36, that's 288 square centimetre. I'll stop the recording there.